Assalamualaikum and hi everyone. First, let me introduce myself. My name is Norani Binti Ibrahim from Archive Digital Communication Engineering. For our mini project, we got a title which is bandpass filter. Okay, our group has been assigned to design a bandpass filter for heart monitoring system based on the ECG signal. First, let me start with the introduction. Okay, what is bandpass filter? Bandpass filter is an electric circuit or device which allows only signals between specific frequency to pass through and heterogeneous or reject frequency outside the range. Bandpass filters are largely used in wireless receiver and transmitter, but are also widely used in many areas of electronics. Okay, heart monitoring systems use heart signal produced during each cardiac cycle. Many types of signals are acquired to analyze heart functionality such as ECG signals. Okay, for this project, we have aimed to design a bandpass filter for heart monitoring system based on the ECG signal. Okay, and next we move to the objective. For this project, we got two objectives, which is first to determine the gain and phase margin of the system in the plot. And for the second is to design a compensator so that the phase margin will be at least 30 degrees.
Hi, I'm Kushalya Nair. I'll be explaining the methodology involved in obtaining answer for part A. So, for part A, we obtain the phase margin and the gain margin with the given transfer function. The transfer function given is Gs equals to 5 times 10 to the power of 4 over s plus 10, s plus 100. By using Scilab codes, we were able to determine the phase margin and gain margin. By entering the values of the transfer function, we obtained a phase margin of 13.5708 and gain margin of 6.8484. This diagram shows the magnitude in decibel versus frequency in hertz plot, while this diagram shows the phase in degrees versus frequency in hertz plot.
Assalamualaikum and selamat sejahtera. My name is Muhammad Imran bin Nur Razman. This is my part. Okay, this is our result for our second objective is to design a compensator so that phase margin would be at least 30 degree. For this case, we are using lag. For step 1, a fine frequency is omega c. For phase is negative 180 plus 30 plus 5 using formula of lag, and the answer is negative 145 degree. So from negative 145 degree we get our frequency which is 1.803 Hz. So in order to convert to radian per second, we multiply by 2 pi and then we can get the answer is 11.3349 radian per second. Okay, for step 2, we want to find the alpha using new gain. Since omega c equal to 1.03, so we get gain from the board plot. Here we got 9.254 dB. So we put formula for gain n equal to 20 log alpha, and then 9.254 equal to 20 log alpha. Therefore, the answer for alpha is 2.9003. For step 3, we want to find the value of z. Z equal to omega c over 10, and then 11.3349 radian per second over 10, and the answer for z is 1.1335.
Assalamualaikum and hi everyone. Here Nur Anis again. I will continue for the step 4. Okay, for the step 4 is we need to find the value of tau. The formula for tau is 1 over z. Okay, the value of z we have obtained from the previous step, which is step 3. And the value that we get, the value z that we get is 1.1335. Okay, to get the value of tau, we need to insert the value 1 over 1.1335, and we got The final value of tau is 0.8822. Okay, next we move to the next step, which is step 5 and actually the last step. Okay, in the step 5 we need to find the value of GCS. The formula for GCS is 1 plus tau s over 1 plus alpha tau s. Okay, the value for tau and alpha we have obtained from the previous step, and we need to insert it to the formula, which is 1 plus 0.8822 s over 1 plus 2.09003 multiplied by 0.8822, and the value that we got is 1 plus 0.882 s over 1 plus 2.5586 s. Okay, by using Scilab, we have obtained the phase margin at 30 and above. Okay, for this case, we got the value for the phase margin is 31.134418. Okay, as the conclusion is we have fulfilled the second objective for phase margin for the value at least 30 degree. That's all from us. Thank you.